This lesson, we are looking into vectors proof. This is a grade 9 topic. We're not looking at the easier ones, which asks you, can you draw a vector which is similar to 2a plus 3b, the simpler ones, that's in grade 5. We're looking into how to use vectors to prove some geometrical problems and to solve them as well. But first, we have to recall, okay, vectors are used to describe direction of lines. So vectors is all about directions, okay? And if OA is A, the other parallel lines with opposite direction will be negative A, okay? Using a different letter means different direction, not as in they're not parallel. So if OA is this one, another line that is not parallel could be a B, could be C, could be D, etc. Okay, each vector could be seen as a journey from a starting point to the finishing point. For example, the vector AB means a journey from point A to B. So your task is to find a route that goes from A to B. All right, we'll talk about that in a bit more details later in the example. To prove, now there are two types of vectors proof question. The first type is, you do want to make note of this, is parallel, and the other one is about collinear. Now, to prove they're parallel, you just have to show one is a multiple of another. For example, you can see AB is 2a plus 3b, DE is 4a plus 6b. But if you factorize a 2 in the DE, you get 2a plus 3b in here. Then you can see they are parallel. Well, because their vector 2a plus 3b is the same. So therefore, you can see AB and DE are parallel. So it's all about one is a multiple of another. So DE is 2 times AB. Essentially, DE is basically 2 times longer than AB. Next one, to prove 3 points that are collinear. Collinear means 3 points form a straight line. So that means they lie on a straight line, very same straight line, without bend, without shortcut, without anything. They lie on the same straight line, like just like snap peas. I know a lot of people don't like snap peas, but anyway, you need to show two vectors made from these points are parallel. So you have to choose. So out of 3 points, let's say we've got point A, B, and C. To show they're collinear, you just have to choose two vectors out of these 3 letters. So you can make a vector AB, a BC, or AC. So any of the two, okay? Any of the two to show they're parallel. All right? The first example, we are looking into parallel. In the diagram, we're given OA equals A, so it's best to put in the symbols in there, put in the vectors, label diagram. OB is B, so OB is B, and BC is 3 over 2A. Now, do note the direction of the arrows. Remember, OA means from O to A, so you must put an arrow from O to A. The direction matters because vector is all about direction. If you go the other way, you will have to be negative A. So, okay, do you follow it? It's like the those moving walkways that you see in tube station or in any airports, etc. So it's one way, okay? They tell you it's one way. You can't go the opposite way, all right? So given N is a midpoint of AC, so N is midpoint of AC, I can use this to show they're equal in length. And P is a midpoint of OB, so P is a midpoint of OB. That in that way, what I'll do is I'll actually rub this off and I'll write that's a half B and that's a half B. You can write the whole thing as B as well. Okay, so I tend to use pencil for any vector question. Write down the vector Bn in terms of A and B. So question A, to write down the vector Bn, first of all, you have to develop a route that goes from B to N. So remember, this journey is from B to N. Now, there are different ways you can go. You can go from B to O, O to A, and A to N, or B to C, and C to N. Now, write down both, B to O, plus O to A, plus A to N. Or you can do B to C, plus C to N. Which one's easier? Well, to be honest, it doesn't make a big difference because BO is just a bit negative B, OA is A, so the trick here is to find out AN. BC, we're given that one, CN, we just have to work out CN for this root. So essentially, they are just both working out this roots in here, AN or N or CN. So it doesn't matter, but this one, hey, CN, BC and CN is 2, and this one is 3. So obviously we can go for the shorter one, which is 2. So BC plus CN. So let's go for this one. Okay, it doesn't matter which one you go from, as I said. So BC, okay, so BC is 3 over 2A, right? So we know that. But what's CN? Now we don't know what CN is, but what we know is CN is half of CA. So CN is half of CA. Now it's not AC, it's not half of AC, it's half of CA, because if we want to go from C to N, it'll be half of C to A, the very same direction. So it's not the same as half AC. Okay, I say again, it's not the same as half AC. CN is half of CA. AN is half of AC. All right. Next, if I know CN is half of CA, then my next focus is what's CA. So what's CA then? CA, I can make a root from C to A. Well, how? C to B, B to O, and O to A. So CA equals to C to B plus B to O plus O to A. Starting from C, finishing at A. So what's CB? CB going in opposite direction will be negative 3 over 2A. BO is going opposite to the direction of the arrows, so that would be negative B. And OA is positive A, so plus A. Minus 1.5A plus A is minus 0.5 minus a half A minus B. So now we know CA is minus a half A minus B. So what do we do next? We need to find out a half CA. So therefore, a half CA now equals to a half times negative a half A minus B, which is negative a quarter A minus a half B. So we can then, ultimately, we now know what's half CA, don't we? So we also know what's BC. So at the end, we can now write BN equals to BC over 2A plus CN, which is same as a half CA. So that is same as minus a quarter A minus a half B. So let's simplify the fraction, or simplify the bracket first. Expand the bracket 3 over 2A minus a quarter A plus and minus makes a minus a half B. The like terms could be collected. 1.5A minus 0.25A is same as 5 over 4A minus a half B. You can do the maths on the side in here if you do want to. So that makes it 6 over 4 minus 1 quarter, which is 5 over 4 if you do need it. Okay, the same thing. So we found Bn, right? Next one. Prove that Pn is parallel to OA. So Pn, we need to find the vector Pn. So what I'll do first of all is, of course, use a ruler, draw up a line from P to N. Right? So I need to show Pn is parallel to OA. So remember, if I want to show one thing is parallel to the other, what should it be? It should be a multiple of another. OA is A. So therefore, Pn should be a multiple of A. So let me write down for you. Okay, so question B. Okay, let me do B in here. Okay, if Pn is parallel to OA, then Pn should be is a multiple of A. Okay, now some of you might be thinking, what does that regular line underneath mean? The regular line underneath it means a vector. Okay, so a vector. So some people like to put a regular line. You don't always have to put it down. When you have a regular line underneath it, it means that letter, that variable, represents a vector, particularly. Okay, but you can put it down, or you don't have to. Look at me. Sometimes I do put it down for the B, but I didn't put it down for the A. So yeah, it's not a must. Anyway, so Pn is a multiple of A. So essentially, what we need to do is we need to find the vector Pn. So let's do that. So Pn. So what's Pn? I need to develop a root that go from P to N. So how do I get from P to N? Well, I can go from P to B and then B to N. Yeah, why not? So Pn equals P to B plus B to N. Starting from P, finishing at N. So P to B is a half B. B to N, we've worked out just now from part A, is 5/4 A minus a half B plus 5/4 A minus a half B. A half B minus half B, they cancel out. So I'm just left with 5/4 of A. Is that multiple of A? Yes, it is, because it's 5/4 times A. So therefore, Pn is parallel to OA. Now, if one asks how much longer is Pn compared to OA, so Pn is 5/4 longer than OA. So it's like 1.25 times longer than OA. That's what the fraction in front, the multiple means. All right. Next example, we are looking into collinear. So OABC is a parallelogram, we're told. Given OA equals A, again, so draw an arrow is a pencil, O to A is A, O to C is C. Point B, or point P divides OB in the ratio of 2 to 1, so 2 to 1. That means as a whole line is out of 3, okay, not out of 2. Next, point M is the midpoint of AB, so they're equal again, okay. Show that C, P, and M are collinear. So to show that collinear, when you make 3 vectors out of these 3 letters, so you can make CP, CM, or PM. Now you can also use, if you want to reverse the order, you can do that as well, PC, MC, or MP. But essentially, these 3 are sort of the same to each other, so you can't obviously use CM and MC. So you have to use CP, CM, or PM. You need, as said, how many of them? 2 out of the 3. We need to prove 2 out of 3 are parallel. So you can choose any of the 2, CP, CM, or PM. Right, I'm going to choose, let's say, just to make it easier, I'm going to choose CP and CM. Make it easier for everyone, just choose the first 2. Doesn't matter which one you do. CP. So first of all, I need to do CP. Let's go. To find the root from C to P, maybe I can do from C to B and B to P. So C to B plus B to P. Now, one thing about parallelogram is the opposite lengths are parallel and equal. So therefore, CB will be the same as OA, which is A. So what we know is that's A. Okay, so that's out of the way. Next, what about BP then? So BP is the one you have to do extra step. So from B to P, now what we know about BP is that it's 2 to 1. So in other words, BP is the same as a third. So BP is the same as a third, remember it's out of 3, of BO. Now I do mention again, BP, BO, same direction. You can't do OB. You have to do BP, BO, same direction. Okay, facing the same way. What BO then? But what's BO? We don't know what BO is, so we have to work it one by one, layer by layer, like onion. The more layers it gives, the more tears you're gonna have in your eyes. So BO. So BO we can do from B to C and C to O. So B to C and C to O. Good thing is the layers stop there because we know BC is negative A and CO is negative C. You can see we are facing against the arrows. So negative A, negative C. So therefore, BP is now a third of negative A minus C, which is negative a third A minus negative a third C. So what do we know about CP then? So finally, we now know CP equals to A minus a third A minus a third C. A minus a third A, 1 minus a third is same as 2/3 of A minus 1/3 of C. Okay, so that's CP. Next, as I said, I chose CM, so I'll do CM as promised. CM. So how do I go from C to M? Well, first of all, what I'll do is I'll probably just connect a line there, CM. Right, so how do I from CM? To go from C to M, I can do C to B, B to M. So C to B plus B to M. CB is A, we know that. Do we know anything about BM? Well, what we know is BM is a half of BA. So BM is half of BA. Now you can be a bit smart in here because we know this is a parallelogram. parallelogram, the opposite lengths are equal again. So that means OC, if OC is C, this one, if OC is C, therefore AB is also C. What it means is BM will be the same as half of negative C. Why negative? Because you can see an arrow pointing upwards to C, but where BM is going downwards. So it'll be negative a half C. So CM is A minus a half C. We need to show they are parallel. So now we've got our two vectors in here, CP and CM. We need to show they're parallel. Well, how? First of all, to show they're parallel, we need the coefficient inside the bracket the same. But what's different here is 2/3 of A and 1A in here. So we can do it for the CP is, we can do a bit of plastic surgery. We can take out the 2/3. If we take out 2/3, 2/3 times something is 2/3 A. So it's just 1A. 2/3 times something is a third. It's 2. Sorry, it's a half. So half C. So are they the same? Well, if they are the same. So we can say here is, oops, sorry. You can say CP is parallel to CM, and C is a common point. Now this line is required. Therefore, C, P, and M are collinear. Later in the practice, when I ask you to show collinear, that's what you show as well. Okay, show they're parallel, and then whichever the common point you've taken from these two vectors, write it down, and then you can wrap up saying they're collinear. Please accept my apologies about this lesson. It's going to be a little bit dry.
Do you know what a meme is?
But vectors, we know vectors quite well, don't we? We just hate it so much. Here is practice question 1. Pause the video, have a go at the question. Now, this has nothing to do with parallel or collinear. It's just testing you whether you can write the vectors AX and OX successfully using the other roots. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here is the final answer for question 1. Okay, check your answer. You can reverse the order as in put 2/5 of B first, so 2/5 of B minus 2/5 of A, or 2/5 of B plus 3/5 of A. But the sign has to follow the term. Okay, if you got it right, well done. But if you got it wrong, I'll go through step by step how to work it out. Okay, so in the triangle ABO, we know OA is A. As I said, we first label diagram, OB is B. Point X divides the AB in the ratio 2 to 3. So that means 2 to 3. So AX is 2 parts and XB is 3 parts. So altogether, they're out of 5. Expressed in terms of A and B, what's AX? So question A. So to work out AX, we need to go from A to O and O to X. But do we know OX? We don't, because if you look at the question, read the question says part B is find OX, so therefore this root doesn't work. So A to O plus O to X, it doesn't work. So you'd be thinking, okay, what else do I know then? Well, I know that's 3 to 2, so I can make use of that. So AX essentially is the same as 2/5 of AB. Right, so that's another information that we know. But what's AB? Can we work out AB? Yes, we can, because AB is same as A to O plus O to B. So AO is negative A, OB is B, so plus B. So therefore AX is 2/5 of negative A plus B. We do usually expand out the bracket in vectors, so minus 2/5 of A plus 2/5 of B, and that's the answer. Question B, now OX. OX, we don't know any information about OX, so the only way we can go about it is to make a root that goes from O to X. So from OX, we can go from O to A, and then A to X. We know OA, which is A. We know AX from part A is negative 2/5 of A plus 2/5 of B. Expand a bracket. Plus and minus makes a minus. Plus and plus makes a plus. 1a minus 2/5 of a is same as 3/5 of a. The plus 2 positive 2/5 of b has nothing to do with it, and that's the answer. Practice question 2, slightly more challenging than the previous one. So see if you're able to work out yourself. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. So question A, AI is a plus 6b. Part 2, OX equals half a plus 3b. Now if you got these two wrong, then there's no point doing part B. I would suggest you try these two parts again and have a go with part B again, because otherwise it affect your answer in part B and there's no way you can work out part B. So but if you want to carry on listening to the answer, yes you can. I'm going to explain step by step how to work it out. All right. So I'm going to read the question first. OABC is a quadrilateral in which OA equals A, AB is 2B, and OC is 4B. All right. D is the point such that BD equals OC. So we're told BD has the same length as OC. So BD is 4B, right? And X is the midpoint of BC. Right, find in terms of OD. So of A and B was OD. So AI, so from O to D, we can go from root from O to A plus A to D. We know OA is A, AD combined is 6B. So that's the answer. Part 2, what about OX? So OX, to go from O to X, we need to go from perhaps O to C and C to X. So OX equal O to C and then C to X. We know OC is 4B, but we don't know what CX is. Now what we look at on CX is they're equal. So use the same trick we've done in example. CX is the same as a half of, now remember, going that direction, so I have to be CB, so half of CB. But what's CB? CB could be worked out from from C, so it's from C to O, O to A, and A to B. Now look at the sequence of the letters I'm choosing from C, starting from C, and then to B. Each of them connecting with each other in the root. So what's CO? CO opposite is negative 4B. OA following direction, so positive A. AB following direction as well, so it's 2B. Collect the like terms. Minus 4B plus 2B is negative 2B plus A. We tend to write the A first. It doesn't matter if you want to rewrite that, but personally I do write A minus 2B. Now, once we've got CX, no, that's CB. So CX is a half of A minus 2B. Half times A is half A. Half times minus 2B is minus B. So now, we now know OX equals to OC. So OC, which is 4B, plus CX, plus a half A minus B. Half A is half A. 4B minus B 4b minus b is positive 3b, and that's the answer. So half a plus 3b. Okay. Now, if you understand part A, the two answers now, maybe have a go at part B again, see if you're able to work it out again. You can feel free to pause video now and have a go. Okay, I'm going through now. Part B. Show that the points OXD are collinear. Now, if you remember what I taught you in the previous example, to show the 3 points are collinear, you need to make 3 vectors and choose 2 of them that are parallel. So you can choose, you can make OX, OD, or XD. Well, you can be quite smart in here because in part A, you've already worked out OX and OD. So why do we need to go all out of the way to work out XD? Apart from it looks like a smiley face. If you know what XD means, if you look at it sideways, it'll become like this. Okay, like a smiley face. That's what it means. Sorry, face. Anyway, so OX and OD, we don't need to do anything else. We don't have to find XD. So all we have to do is to show they're parallel and to say O is a common point. So let's do that. So we know OX and we know OD. Oh dear. Sorry, lame joke. Part B. So OX, since OX is a half A plus 3B, let me rewrite that. And OD is A plus 6B. We need somehow to show they're parallel. To conclude, we can see they have no common coefficient in here. That's a half and a 1. So if I factorize a half in here, half times something is half A, half times A. Half times something is 3B, so half times 6B. Half times 6 is 3. So therefore, you can see they're parallel. A plus 6B, A plus 6B. So because OX is parallel to OD and O is a common point, don't forget this line is a common point. Therefore, OX and D are collinear. Here's the last practice question, even more challenging than the previous one.
I don't like where this is going.
I would suggest you use a pencil so you can sort of rub it off and try again if you need to. So pause the video, have a go at the question. When you're ready for the answer, or if you have no clue how to do it, you can play the video. Here are the answers for question 3. Okay, I left out part C because to show that MQR is a straight line, you do the same thing like the previous step, previous question to find MQ and QR is a collinear, parallel, etc. And if say M is a parallel point. If you know the proof, you know the proof. So here the answer. If you got it wrong, you can feel free to try any of them. You can pause after explain a certain question. You can have a go and try it again. That's the best thing you can do to revise. That's the most efficient way. You try again, so you listen to the parts that you've gone wrong, and then try to do it again with the correct answers. All right. So if you've got anything wrong, I'm going through it at the question one by one. So in a triangle OMN, OM equals M, and ON equals N. The point P is a midpoint of MN, and Q is the point such that OQ is 3 over 2 of OP. Now this one I've not used it, so I'll probably put a box next to it, means I have to use it later. Question A. Find in terms of M and N of OP. So what's OP? So question AI. From O to P, let's develop a root. From O to P, I could do from O to M plus M to P. We know OM straightforwardly is M, but we don't know MP. What we know MP, on the MP line, you can see there's a little stroke in there, means it's a half of MN. Do we know MN? We don't, but we can work out, don't we? So MN, same as M to O plus O to N. M to O, against the arrow, put a negative. O to N plus N. So therefore, MP is a half of minus M plus N, which is minus half M plus a half N. So what do we know about OP to find the answer? The OP is OM, M plus minus a half M plus a half N. So if I simplify the fractions, M minus a half is same as a half M plus a, and then plus a half N. That's the answer, right? Question 2. What's OQ? Now OQ, that's when I've used this information. OQ, part B, we're told OQ is 3 over 2 of OP. So that's the same as 3 over 2 of, we found from part AI, OP is a half M plus a half N. So 3 over 2 times 1 over 2 is 3/4 M. 3 over 2 times a half is 3 over 4 N. And that's the answer. Part 3, I don't mean part B, sorry, I mean that's part A part 2. A part 3. What's MQ? Well, MQ, now MQ, you can, we develop a root from M to Q. Now there are different ways. You can go from M to P and then P to Q. The thing is, you have to think a step ahead. Do you know PQ? Not really. So if I don't know PQ, is there another way I can go to Q? I can go from M to O and O to Q. You should use what you have calculated, which is OQ. So M to O, O to Q will be much easier than M to P, P to Q, because you already have the information about M to O and O to Q. So MQ equals M to O plus O to Q. MO is against the arrow, so it's negative M. OQ, we've done in part 2, is 3/4 M plus 3/4 N. Minus 1 plus 3/4 is minus 1/4 M plus 3/4 N. And that's the answer for part 3. So the point R is such that OR equals 3ON. Now, when you think about where is the position of R? Now, OR means from O to R is 3 times the distance of O to N. It means OR is parallel to ON. And in fact, because they share the same point O, it means O, N, and R belongs to the very same straight line. So if I put R in here, let's say R in here, and then use a ruler, join them up. What I know is the distance from O to R is 3 lots of distance of ON. That means the distance from O to R is 3N. So in other words, ONR is 2N. Okay. Part B. Find in terms of M and N the vector of MR. So MR, mister, we can go from M to N and then N to R. Or you can go M to O, O to R, same thing. So M to N, do we know MN? We don't. So actually, that might not be a good idea to do this. Instead, we should do M to O plus O to R. Now that works. You can work on MN, but if we know M and OR, why do extra steps, right? So MO is negative M, OR is 3N, and that's the answer. Minus M plus 3N. Part C. Explain why MQR is a straight line. So M, Q, and R. So M, Q, and R. So M, Q, and R, two vectors, MQ and possibly maybe MR. Okay, so what's MQ? Have we worked out MQ? Yes, we did from part 3 in question A. So MQ equals to minus 1/4 M plus 3/4 N. Do we know? Let me rub that line. What's MR? Do we know MR? We just work out MR is minus M plus 3N. Well, if I do a bit of factorizing for the MQ, so by factorizing, now compare the coefficient. There's no quarter in there, so if I factorize a quarter, that'll give me minus M plus 3N, because a quarter times minus 1M minus 1/4 M. A quarter times 3, 3/4. So we can say, therefore, because MQ is parallel to MR and M is a common point, so we can say, therefore, M, Q, and R form a straight line. All right. Last but not least, find the ratio of MQ to QR. So before we do that, why don't we just draw a straight line all about M, Q, and R. So we got M in here. Have a look at the diagram again. So Q is there, and R is here. Now, if you look at the diagram, hang on, it doesn't make a straight line. Now, why? Because it means my R is not sort of long enough. I should have extended in here, so R should be here. Anyway, now we can use part C to help us to work out this answer. We know MQ is a quarter of minus M plus 3N. MR is minus M plus 3N. What it means is MQ is a quarter of MR. So MQ, this part, is only a quarter for the whole line. So in terms of ratio, so if that's a quarter of the whole line, in terms of ratio, this will be 1 to 3, because the whole thing is out of 4 parts. So that's 1 part, and that's 3 parts. So therefore, MQ to QR is 1 to 3. Or using the fraction a quarter when it comes to factorizing. All right, so I hope you have a better idea how to prove two vectors are parallel and about from factorizing, and 2, how to show 3 points are collinear. A very, very common type of harder proof question. I hope you find success with them in the exam.